Hey, greetings and welcome to the channel. Today we're going to be looking at querying native tables in Bigquery. So please remember to like, share, subscribe, and most importantly, reach out to me in the comments. I'd love to give out help as well as receive help as we go for our job certifications, as we go for our certifications, or we go to hone our skills. So let us get started. So today we're going to be looking at querying native tables in Bigquery, not the external tables. We could query external data, but tables that are in Bigquery. So what we're going to do is we're going to set up our front end. We're using a down git and down hit git. Once again, it's really great at when you don't want to download a whole repository. Definitely want to use down git, right? Set up our front end, which we already have here using these commands, then download our back end, install the Python packages, and set up the back end like so, right? So definitely in this lab, what we're going to be having is that when you do this lab by yourself, you can see in this GIF that what you want to do is you want to be able to copy and paste the code, the query from the code, right? That's commented out, and go ahead and paste that in the go ahead and paste that like so in the front end. That's what we're going to look at today. So let's start off with interactive queries. Right, so interactive queries are the queries that execute immediately in BigQuery. These are just done by default. We're just going to take a look at how that sets up like so. And then what we're going to do is we're going to update our front end environment so that it can actually populate that AG grid that we have there. Right, copy the code like so. Right, and copy and paste according to the GIF. Right, even though it's not formatted well, definitely leave in the comments what can happen, right? We see this is interesting, right? Query data immediately returned, right? So that's an interactive query. So that batch queries, they're used when you don't need the answer right away. I just want to show you how a batch query would go. Go ahead, update that environment, and update the backend environment. And copy like so. Right, and then we see in our query config, we see this little code that we added here. Right, and now we see that our job is currently in the state pending. Definitely when I look in the BigQuery UI, I don't see any jobs created, so I'm not sure if I'm looking in the right spot or this is actually ended up somewhere else in someone's account. Definitely leave a comment to help me find, and definitely if I find it, I'll update it lab, which I'll post in the link in the video description. Next, we're looking at dry runs, and dry runs are very good if you just want to see, if you want to avoid making expensive queries. Like we're going to see right now, if you're going to look at the code for a dry run, we're going to select this query, and we're going to see how much data that we have to do, that BigQuery has to process, and nearly a gigabyte, right? So that might be a bit expensive, right? And then if I just go edit the query, right? Oh, right. And then I think what it was, I had a little aggregation if I'm selecting all, but I'm not using any aggregation functions. You need to remove that group by class. That's okay. But say if you try to select the whole table, right, you see it significantly increases. So this definitely helps. Like before you run anything, use a dry one, which is actually free. So when we make queries using with BigQuery, what happens is that the data actually gets stored in a table which it's really hard to get access to. However, the solution here is to write them to a permanent table like so. Right, and here we're going to have our data written to the table in our data set. And I don't think I think I forgot to update the, okay. Right, so we look at, we're going to refresh the page. Obviously, the UI doesn't update. Right, we get to look at our data. I want to preview it for a bit. We're going to create a table. Select star. And then I don't expect it to be too much, right? So we get to see our data like so. Very nice. All right, so now your queries are actually saved to the table, which is very, very nice. So definitely you could see that those tables are empty. These tables are usually empty beforehand, and you're able to upload that data. I wasn't able to show it directly, but if you have empty tables, it's a great way to write create a permanent table for all the extra setup, right? The schemas get to come along, as you can see there, right? You can see the schemas immediately come along, as you can see, according to the query that we had, and the table is populated as needed, right? So it's not much on your part. So it's always good when you're using BigQuery, you're using their SDKs, always want to work with SQL. Try not to use the SDK to do things. It's a lot of extra steps in there. So now, when BigQuery also implements query caching, which means that if you have the exact same query, instead of BigQuery to process it again, it will use the cache in order to give the proper result. Right, definitely useful. And we could see here, right, we could set up our query to run. We could see, and we could use the cache hit property to see if the query was cached, if the query result was cached or not. So what we want to do, we'd like to say use query cache equals true, but that doesn't really allow it to work. What we want to use is the create disposition property to create never, right? And then you also want to run this twice, because if you think about it, all right, that's interesting. The query was cached maybe from a previous, I should have made a different query, but usually when it doesn't work, you want to run it twice. You want to run the query twice so that the query can cache out. Right, so parameterized queries are very, very important to use in when you're working with full stack applications, because SQL injections can occur. You just can't have your query stand alone. Instead of to use format strings to really solidify what you want in the query, I'd rather use BigQuery actually provides a feature here where you can actually provide those parameters so that certain data that you want to keep away from the internet and the front end UI, right, can be kept like so. So now we have a query here, which is just a regular name, and we can see here that the corpus is, so the corpus or the title is only Romeo and Juliet, and the word count is less than 250, right? Just probably this developer is trying to save space, doesn't want to use megabytes, as we saw in that dry run, right? And we can see our query data is returned, right? And another good useful thing for parameterized queries, which you can't express with format strings, is that we have solutions for arrays, right? If you try to maybe arrays, timestamps like so, right? You definitely won't be able to easily express that timestamp, right? Even though like you can convert it. I think the point here is that BigQuery offers something in favor. Definitely want to use it. So definitely on your own time when you're doing this lab, definitely want you to take a look and get that to work. All right, so now for wildcards, definitely want to turn this back to false. We won't be using that table anymore. So wildcards allow you to select from several tables at once. We're going to see it. We're going to have a dry run and see what that looks like. All right. Okay, so here is our query like so. Right. And then, I don't know if it's too obvious, but yeah, it's going to zoom in. It's going to actually close it up. Should change the height on it, but that's okay. But here is our table. Here's our table, and here's that asterisk. So basically, there's several different tables with like the same prefix but different suffixes. Let me see if we can find one. Then add public data sets. Let me see. It's actually pulled up here. New data set like so. It gets added. So that's our data set. And then we kind of see here 1929, 1933. So like so, right? So if in our query, we're asking for table suffix 0 or 4, now we're looking at 1940 and 1944, right? And then we could see that that query processes X amount. That's the data in those tables combined. And then if you change it up, if you play around with the SQL, right, you could get different results. So that's very, very nice on the part of BigQuery that allows us to work with multiple tables. All right, so next we want to look at is scheduled queries. And sometimes you need your queries to execute repeatedly instead of trying to have your backend handle this. BigQuery uses BigQuery data transfer API in order to allow this to happen. And when BigQuery, really, the rule of thumb is when BigQuery offers a service to do something that you could actually replicate easily in the backend, don't easily replicate it in the backend. Actually use their service to do it. I'm not as too sure as to what use cases you want to have BigQuery have things scheduled, other than if your backend fails, you lose the state in terms of scheduling for your timing, and you rather have the cloud actually maintain schedule than your backend, which might fail. So what we have here is our environment is set, and now we're going to run our query, right, to execute every day. And we can see that in the code here that our schedule executes every 24 hours. And in the resources, right, for this lab, we're going to try to link to the syntax about how if you want to configure it to run every day, every month, on a certain time frame, and get more complex with that with the cron job if you'd like. So what we do to look at that in the UI is we want to go to scheduled queries, simply scheduled queries, and now we can see it's running, right? The time is 8:55, like so, right? And what we have this query do, right? We take our table and then we write, not sure if you update data here, but let's take a look at the table and see what the table looks like, right? And create data set, and then we want to refresh because this executes immediately. Right, so it's kind of weird because I expected a table to pop up immediately. However, we could take a look. Yeah, and I wouldn't expect it to be in there. Or we could take a look. That's okay. We could actually take a look with checking the schedule status of the query. Want to see if the query actually went through or not. Usually, scheduled queries on their schedule, right, they execute immediately. But this is interesting. Take a look at what's going on here. All right, so there's really no query to ask for here. Go ahead and hit submit in the front end like so. And then schedules every 24 hours, right? So obviously it's not going to tell us too much information, but if you want to take a look into that, really that's how you set up the scheduled query. Definitely interested as to why it's not immediately executing like so, but it actually does. Right, but however, I'm going to try this shaky code here, manual runs. Like definitely, when dealing with advanced concepts with Google APIs, I felt like BigQuery would have this down and this taken care of. I'm not too sure. I think this is error on my part. However, I'm gonna try to use this code. I know this code is shaky, and I'm actually gonna try it to see if I can actually immediately trigger this run. And what we want to do is we want to go ahead and take our project. We want to take our schedule query, the name of it, and actually paste it in the text box like so, and then try to make sure the environment's set up, and let me see if this manual run is actually going to make things happen here. Right, run refresh like so. It does not populate immediately. Right, and it kind of seems that, right, so that it's enabled, so that's what made it work. It really kind of seems that I might have to start there on the runtime, right? So the current time is very different. This is clearly in a different time zone, and it's a bit interesting. So it kind of seems, so I guess, if scheduling a query run doesn't immediately execute it, right, you want to use this code, go ahead and manually and start that scheduled query. And the last thing is for this lab is if you want to delete that scheduled query, right? Say for example, you kind of realize that that query is taking up too much data or it's running too quickly, right? We could go ahead. We don't have to delete in the UI. We could also use our backend here and go ahead and delete like so. But remember, you want to always keep that scheduled query, the name of that scheduled query, right? And then scheduled status gives out a lot of information. Try to indicate which one is needed. Right? We hit submit like so, and then it is deleted, and then we don't have any issues from the cloud. It kind of shows that once it's deleted, it's taken care of. So that is the lab for querying native tables. Please like, share, and subscribe. And most importantly, reach out to me in the comments. I love to give out help as well as receive help as we go for our jobs, as you go for certifications, or we just want to hone those skills. And a link to the lab will be posted in the video description. Thanks for watching.